We left off last time with a discussion of the study by Gordon Pennycook and his co-authors on the reception and detection of pseudo-profound BS. This is where instead of looking for facts that we can potentially falsify, that we can try to prove or disprove, we tend to prefer, because of our need for closure, we tend to prefer vague generalizations that use such vague terms that they could mean anything we want them to mean. And so they feel good and they give us the feeling that we have an answer, but they're actually so vague that they could mean completely opposite things. Or they could be very inaccurate and very unhelpful if we try to turn them into actual action. And they don't give us a very detailed and accurate understanding of the world. But they feel good because they satisfy our need for closure, need to rest from this search for new answers to new questions. And as Pennycook and his colleagues observe, there's a motivation in BS that it attempts to impress other people rather than to actually inform people. So an argument of persuasion works this way. Motivated reasoning works this way. An argument of persuasion is focused on convincing other people you're right, even if you're not. And BS seems to be part of that. It uses motivated reasoning. It begins with a conclusion, tries to persuade others to accept it without adequately investigating its accuracy. But the opposite of that is critical reasoning. This is the attempt to falsify a claim, even if it's the claim that you want to prove. You can't prove it by just using confirmation bias. You have to look and see, is there a way this could be proven wrong? Now let me see if I can do that. And if I can't prove it wrong, then I can be a little bit more confident that this claim is stable and specific. But to even describe how BS works in terms that are clearly not BS, Pennycook and colleagues write a typical academic journal article. They don't say, in society today, people believe a lot of BS. That's not something that could be falsified. That's not something that could be disproven. So what they have to do is be a lot more specific with their claims and the evidence they use to get to that point. And informing, using critical reasoning, using an argument of inquiry, requires not just the conclusion, and certainly not a generalization, but a specific falsifiable conclusion, and then evidence that you have tried to falsify it, that you have gathered as many specific facts as you can, and then show your reader. Assume that your reader is someone who knows a lot about your particular field, the thing you're writing about. In this case, the article was published in the Journal of Judgment and Decision Making. So this article is written for other people who do psychological research on judgment and decision making. Psychologists, behavioral economists, sociologists, and that sort of thing. And so you can't just say, here's a generalization. You have to say, here's what we set out to find. Here's what we thought we might find. Here are the ways we set up these tests for the test subjects to take. Here are the actual numbers that we got. Here are the answers we got tabulated into a table. Here's how many people said this. Here's how many, the percentage of people that said that. And we looked at that evidence and we drew these conclusions using these inferences. And so an academic article maps out that whole process. It doesn't start with a conclusion and then come up with confirming evidence, and it doesn't use logical fallacies to make something seem reasonable. It shows you the entire thinking process that the researchers went through. And that's why academic articles are written the way they are, in the particular format they are. So a typical academic article has what's typically referred to as the IMRAD or IMRAD format. It starts with an introduction, or at the top it'll have an abstract that briefly describes the conclusions and how those conclusions would come to. But then it starts with an introduction that gives some background on the situation, the thing being studied, the issue, the question that was posed, and then it gives the purpose of that particular study. Then the M stands for methods. It says, here's how we set out to test this. Now the methods might be bringing people in the case of the Pennycook study, bringing people in and having them read these quotations and then answer questions about them. That's one method of gathering data. If you're a geologist, you're going to go out to a geological site and study the rock formations. If you're an engineer, you're actually going to have the equipment that you're testing to see what results you get. Or you may just be doing a library research. You might see how many times 19th century novels use references to consciousness and unconsciousness, that sort of thing. But you describe whatever those methods are here. So it's important that your reader not just see your conclusions, they need to see not only your evidence and your conclusions, but how you got the evidence and how that evidence led you to that conclusion. Then, after you describe the methods, you describe the results. We set out to do this, here's how we did it, and then here's what we found. A lot of times this will be numbers. This is where a typical academic article will get really boring if you're not into statistics. But it's important that those results are there rather than just jumping to the conclusion. But the discussion, the conclusion, comes after the results, where they interpret those results. They say, from these results, we have drawn these conclusions. This form takes its shape from the way the scientific inquiry method works. A lot of speeches or blog posts might adapt the argument of persuasion framework, where you actually start the article with a conclusion and then you list out a lot of anecdotes and that sort of thing that make that conclusion seem more likely. But an argument of inquiry is going to follow the scientific method, because the scientific method was set up for this purpose, with the recognition that individual scientists doing individual research are likely to start with a conclusion and cherry pick evidence. They're likely to use confirmation bias even if they don't realize they're doing it. So the scientific inquiry method is set up so that you try to prove yourself wrong first, and you write about it as you write your article, as you do the experiments, and then you submit that description of that inquiry process to other people who are experts. So the typical scientific inquiry starts with making observations. Now, you're making these observations already knowing about research people have done in the past, so you've got general theories that sort of guide your observations. When you're making those observations, you are looking at facts, according to the definition that we established in the last lecture. Something that is a particular incident, particular information that is verifiable by other people. If someone else was standing there with you, they would see exactly what you're seeing. So you observe the facts, but then you start to make inferences from those facts. You think of interesting questions that you might ask yourself about those facts, like what caused these facts to be this way? Is anything potentially going to change this? Could I change it and make some beneficial outcome by intervening in this process that's already at work? Something like that. So you think of interesting questions, you make inferences, you formulate hypotheses. And a hypothesis isn't just a speculation. It's not just, I think this kind of thing would probably happen this way, or I think these things are all alike in this regard. But you actually look for something that is falsifiable. You make a hypothesis that is a claim that can be falsified. If it's wrong, you can test it and find that it's wrong. And then you do just that. You try to prove it wrong. You develop a testable prediction. You gather data to test that prediction. And then you decide, is this enough for me to develop a theory, or at least argue to claim that we can make this into a theory. And if not, I might need to do more experiments. I might need to refine, alter, expand, or reject these hypotheses. If I come across too many anomalies, too much counter evidence, then I need to change the format of the experiment a little bit to see if I get the same results or something slightly different. I need to have a control group, a group that I can compare to the experimental group. The experimental group is the one that I'm making adjustments with. The control group, I'm not making any adjustments with them. I'm just seeing if the outcome of the experimental group is an ordinary one, or if it's actually something different. We'll talk more about that when we talk about case studies later in the week. But once an individual researcher has gone through this inquiry process, it's not over. So this inquiry process exists the way it does because facts don't exist by themselves. They cannot explain anything by themselves. We make inferences from those facts, and those inferences themselves have to be examined. This is probably a good point to distinguish between theories and facts. A fact does not become a theory. People used to say that a theory they didn't understand was just a theory, as if that meant it's just speculation. Because in common language, we use the word theory to mean just, here's some idea that just popped into my head out of nowhere, and I call that a theory. But that's not what a theory is. It's certainly not what a scientific theory is. A scientific theory has been tested through this process. And a theory explains the facts, but a theory cannot become a fact. You might think of a theory like an architectural plan, a blueprint of a building. That blueprint cannot become a building, but it can guide the assembly of that building. It can say that here's the structure of that building. Here's how that building was built. But the paper that has that plan on it, or the CAD program that shows the format of that building, that doesn't actually become the brick and mortar building. So theories are these explanations. They start with inferences, but they're inferences that are examined every step of the way. And we need other people to help us examine those inferences. We want to make sure somebody's checking to make sure we don't accidentally use confirmation bias, that we don't accidentally slip into an argument of persuasion, that we have done the inquiry process to the letter. And that's why peer-reviewed journals require the researcher to write up this entire experimentation process, this entire research process, and make that visible to experts in that field. So a particular academic journal will be maintained and reviewed by people who are experts in the field that journal represents. So to get published in a peer-reviewed journal, an author is going to write and submit an article about this research. Now, it might be scientific research, or it might be research in the humanities, which is mostly book-based. It's looking at the literature that other people have written, or it's looking at the products of culture, and that is the data set that someone is using. But whatever type of research they're doing, an author is going to write that research process up, not just the conclusions and not just the evidence, but also describe specifically the connections between the evidence and the conclusions, and then submit that to a journal editor. And the journal editor is then going to send that writing to other people who are experts, and they're not going to see the name. It's going to be completely anonymous. They're not going to see the name of the person who wrote this paper, just in case it's someone they know, someone they respect, one of their former students, or one of their former professors, or someone whose work that they admire. You want anonymity. You want them focusing on the argument. And this diagram comes from the TAMU-CC library description of the differences between scholarly and popular articles. But I don't think it really clearly depicts the process of review. I've been a reviewer for several academic journals, and I have that responsibility when I'm a reviewer to take the hammer, or at least the scalpel, of falsification to whatever is being written. And so you might think of reviewers as more like sharks in a shark tank. You're throwing your work into this shark tank, and they're going to tear it apart. Anything they see that's wrong, or just not specific enough, not testable enough, not well-grounded enough in the data, and any inferences that aren't justified by that data, the reviewers are going to be like sharks with a red pen and cross that out and say, there's not enough data for this, or you need to go back and read these other articles about this same topic of research. You need to check your methods against these protocols. All of this sort of thing. Anything that's not absolutely falsifiable and inferentially valid, these reviewers are going to point out, and then they're going to recommend whether or not this article should be rejected by the journal, or whether it should be accepted under certain conditions of revision. So almost never is an article submitted for review and passed along to be published without a lot of revision. So usually, after the editor sends the reviewers this article, they'll make all these recommendations about what needs to be changed, what needs to be added, what needs to be taken out. They'll send that back to the editor. The editor will send it back to the author. The author will try to accommodate those demands. And there may be some disagreement between the author and the reviewers, but the author then has to take those counter-arguments into account. Even if the author is going to disagree with what the reviewers are saying needs to be done, the author at least has to address that in the article. And then after it's rewritten, it goes back to the editor. Usually the editor again sends it out to the reviewers and asks them, has this author met your needs, or at least has this author addressed the criticisms you've made? And if they agree, then that article goes on to be published in the next issue of that journal. And this is about as good as you're going to get as far as reliability in a source. It's not perfect. We're going to, later in the semester, we're going to look at some examples of peer-reviewed articles that have been wrong. But this is about as good as you're going to get. A blog post, even a newspaper article, a TV news story, even highly respected articles in journalistic newspapers and news outlets don't go through this level of examination from the top experts in the field the way academic peer-reviewed articles do. Even an article about BS has to go through this process specifically to prevent any kind of BS from being published. Now, I'd like to be able to tell you that peer-reviewed journals don't publish BS ever, but unfortunately, this process, as critical and as rigorous as it is not perfect. In the mid-90s, the physicist, professor of physics at NYU, published a paper in a journal that was focused on epistemology. Epistemology is the study of how we understand what we understand. It's how we know what we know. What gets between us and direct experience of the facts. The ability of culture to shape the way we see things. The social pressure that we're under to come to certain conclusions rather than others, even if they may not be the best conclusion. Epistemology is a very important discipline, and the study of it is extremely relevant. But in this case, this particular journal, what so-called wanted to point out was that this study could easily go off into its own sort of cultural realm of expectation that becomes detached from rigorous, falsifiable claims. And in order to prove this, he submitted this article that he knew was meaningless. He intentionally made it meaningless, but he used a lot of familiar phrases that are used in the study of epistemology. And by doing so, he put a lot of things in that the reviewers would have recognized. They would have seen theories that were popular at the time, and they would have been less skeptical of what they were publishing. And so they did the sort of confirmation bias thing, even though it wasn't their own article. And they recommended the article for publication, and as soon as that article was published, Sokol then published in another journal what he had done, how the publication of this journal article was itself an experiment to see if a deliberately meaningless article would pass peer review. And in this case it did. And that led to a lot of reflection and investigation and discussion about how to make all peer-reviewed academic research more falsifiable, even in the humanities. And so, as embarrassing as this publication was for a lot of academics, it was also a very necessary attempt to falsify the very idea of peer-reviewed academic journals. And whenever you find a problem, the best thing to do is not to persuade people that it's not there, but it's to inquire into it. How did it work, and how do we fix that problem? But because an argument of inquiry is focused on finding out where you're wrong rather than convincing other people you're right, that's why it's still the most reliable. That's why peer-reviewed publications are still the most reliable sources you can have. They're far better than the kind of thing that's normally going to come up as soon as you Google something. For instance, if you heard that coconut oil was good for you, in fact it could help prevent cancer. There was a series of articles that came out on a lot of popular blogs like Lifehack and omgfacts.com, and they all referred to one or two actual studies that were peer-reviewed studies, but these articles themselves were not peer-reviewed, and they were written by people who were not experts in the field, so they severely overgeneralized the specific findings of these academic articles. And what they actually published was completely wrong. And in case studies in this class, we're going to look at specific incidences where actual academic research and actual facts were reinterpreted and then reinterpreted again, and they were described in terms that were completely misrepresentative of the actual facts. So that's why it's very important that you ground your claims in facts. And in this class, you're not going to be able to go out and do all your own research. I don't expect you to go to the engineering lab, and I don't expect you to get in a boat and go out into the Gulf to survey fish populations in order to have original facts that you can then use in your papers. You're going to be dependent on other sources, so that's why it's very important that they're rigorous sources, that they're peer-reviewed sources when it comes to facts. Now, not every not every fact, especially like newly collected data, surveys and that sort of thing, may not have had time to go through the peer review process yet. So you may depend on a newspaper or something like that for that data. You may depend on a website like the one I used in the last lecture, the U.S. Geological Survey, the site that collects all the information about earthquakes in California and elsewhere. But whatever your source is, you want it to be as rigorous as possible, and you want to cite it. So when you cite your sources, you take into account the research that's already been done. That way you don't have to go redo a lot of research that's already out there. But it also means that you become aware, you have to inform yourself about what kinds of research has already been done and what is left to be done. Of course, we cite our sources in order to give them due credit so that we're not plagiarizing, we're not just ripping off somebody else's work. But when you cite a reliable source, you also relieve yourself of some of the burden. If it turns out that that study that you cite depended on too small of a data set, if it depended on a survey of 200 people and it found one result, but then later when 5,000 people were surveyed that found a different result, well, that's not your problem. You've cited that source, and at the time you did the research, if that was the best source available, then you did as much as you can do. So citing your sources kind of relieves you of some of the burden of having to know everything on your own. And it gives your reader the opportunity to review and criticize the truth of that data, the methods by which the evidence has been gathered, the potential conflicts of interest, potential misinterpretation, all of that. In other words, if they doubt your description of that data, they can follow your citation back to that source. They can read that article, they can see the exact data, and they can determine whether or not your description, your generalization of those individual facts is warranted.
So now that you know the relevance and utility of having peer-reviewed sources, where do you find them? Nearly all of us, when we're looking for information, go straight to Google. When it comes to actually finding reliable sources, that is not going to be your best option. We've already read in this class so far about how just looking something up on Google gives us the illusion of knowledge. It leads us to assume we know something about that. It leads to a lot of confidence without actually leading to a lot of understanding. So where do we get better sources? Well, you can start right here with the TAMU-CC library. Many of these articles that are written and peer-reviewed and become part of scholarly journals cost money to view. And if you look them up on Google, you'll see that even if you're able to find the right article, you'll find that you get to the publisher's page and it says, if you want to read this article, pay $35 and log in here. And you're probably thinking that's ridiculous. There's no way I'm paying $35 for a single article for this project. But you don't have to do that. Luckily, as a TAMU-CC student, you have access to a lot of these articles because the university library pays for subscriptions for its student population to access these articles. But that means you've got to go through one of two ways to get to that article. So to find a peer-reviewed article, go to the library homepage. It's library.tamucc.edu. And then go down to advanced search. Don't type in anything just yet in the main search bar. Go right below that to advanced search, and that will take you here. Here on this advanced search page, you can type in the name of the author. If you know of an author, you can type in the subject terms by themselves. If you know a particular title, you can click on the drop-down menu and change the search criteria to title. At first, you're probably going to be looking for keywords, in which case you use the subject terms choice on the drop-down menu. And then, very important, look down to the section that says limit your results and be sure you've checked the box that says scholarly peer-reviewed journals. The library has, in its search database, it's got all sorts of sources. It's got the New York Times and it's got local newspapers and all sorts of sources, many of which are not peer-reviewed. If you want to limit your search results to peer-reviewed articles, you have to check this box. So you check this box and then it will bring you a list of only peer-reviewed articles that address these search terms. Another way, despite all its problems, you still have an option with Google, but that's not going to be from google.com. If you type in scholar.google.com, you'll go to Google Scholar, and that is a very different search engine and will bring you very different results. So if you go to scholar.google.com and you type in the keywords you're looking for, it's only going to bring up peer-reviewed academic articles. But again, a lot of these articles are behind a paywall. That means that they're subscription-only articles. They're part of journals that you have to buy a subscription to, or you have to pay a ridiculous sum of money just to read the one article. But if you do this while you're on campus, you'll notice that on the right, you'll see certain articles that are available that say, get full text at TAMU-CC. So if you're on campus, if you're logged in on campus, you'll see this, and if you click on that, it will take you to the library link to that article. If you're off campus, sometimes there will be access to those articles, and you'll see that on the right. It might be an HTML or a PDF that you can download. That's going to be rare, so you don't want to depend on sources that are freely available, just because that's going to limit the number of articles, the number of sources that you have available. But when it comes to looking for sources, we want the relevance to be determined by something other than just availability. So it's very helpful to use Google Scholar if you're off campus, to see what's available. But if you see an article that looks like it's really relevant to your project, then record the title and the author's names, and then go to the previous method, which is go through the library database and look up those search terms, the author's name and the name of the article. And you might be able to find something through the library webpage that we do have access to, even if it doesn't come up on Google Scholar. And once you find the scholarly articles that you need, it's not over yet. We've typically fall into this problem very similar to the problem discovered in that Matthew Fisher study about people using Google. It's that once we look something up, we think we've done the research, we think we know it, when all we may have done is saved this article on our computer. Just because you have the PDF of this academic article saved, that doesn't mean it is now a source. You have to actually read it. That should sound obvious, but we fall into this trap, this feeling of knowing when we've done this research that our computer now has this information, but we still don't have that information in our heads. There's a great German term for the kind of knowledge we're looking for here, which is Vorhandenheit. It means literally to have something in hand. So if I own a hammer, but it's at home in a toolbox and it's not close by for me to use, then I don't really have a hammer, do I? I have to actually have the tool in my hand in order for it to be Vorhandenheit, ready to use. So the state of having knowledge ready to use in your research, ready to use to interpret new knowledge, that requires actually reading the sources. So don't feel like you've done all you need to do just because you've collected sources. The next step is to read them, and read them continuously as you find them. Even if you find that the source that you've just acquired is not necessarily relevant, it's always going to help you to understand your issue a little bit better, even if you decide not to use that source ultimately in your writing project.